Today we're going to talk about limits and what happens with them as we get close to infinity. And we may have a couple other things that we try to clean up at the end, but I really want to get to limits and infinity first. So let's consider, we're going to consider a couple functions that act, well, it's just kind of interesting. Let's consider f of x equals 3x to the fourth minus 2x cubed plus 3x squared minus 5x plus 6. This big, long, honking polynomial. We're going to consider that, and we're going to also consider just 3x to the fourth. All right? Now, this is a good place for us to use the graphing calculator. So what I want to do here is I want to put both of these functions in. First, the long one, 3x caret 4 minus 2x caret 3 plus 3x squared minus 5x plus 6. Okay, I'm going to put that one in as my y1. And then as my y2, I'm just going to put in 3x to the fourth. Now let's make this second one bold. So scroll over to the left of the y2 to where that little line is and hit enter. That will make it bold. All right? Now, let's start kind of small, all right? Let's just see if these show up okay on Zoom Standard. They do, but let's close that window down so we can see it a little bit better. Let's make it like -3. Okay. Oh, yeah. -3 to 3. And we don't need all those negative y's. Let's make it like -1. All right, that shows it a little bit better. We can see that there are two distinct functions. Okay? So, I'm going to put that in to the notes in case we want to draw on it. So here's the first situation. Okay, this is what we would call a small window. And we said it was like, -3 to 3. All right? Now, let's go back to the graphing calculator and let's blow this out a little bit. Let's make this maybe -100 to +100, and we'll go up by tens. This might be too far. I don't know. Let's just see. If it is, yeah, it's a little too far. So let's go back, and we had went -3 to 3. Let's go instead maybe -20 to 20 and go up by 5s, something like that. Still looks bad, doesn't it? I've got a little preview screen there. We'll just go -10 to 10. What happens here? You have to play with these a little bit to get to what we're really wanting.
You're going by 5 still. What is it we're wanting?
Well, you're going to see that they start resembling each other once we get out far enough. Let's do this. Let's make my y maximum just 5. That's going to help a little bit.
You're still going by 5.
Okay, I looked up in my notes and found a better window here. Let's go -20 to 20. Now remember what we're doing. We're doing a limit as we approach infinity. So let's go out a little bit closer to infinity, like -100,000. And our y maximum will be 500,000. And of course, we need to make our scale like 100,000. Otherwise, it'll try to put in way too many tick marks. Now let's look at the graph. And what you're going to see is that as we zoom way out, the two functions look exactly alike. Okay? They actually basically laid on top of each other, at least it appeared to. All right? So I apologize that it took us so long to get there, but this is a large window. And on this one, we went -100,000 to +500,000. Okay? Now, what we see then is that as we get stretched out, all right, these two functions behave just like 3x to the 4th. So I want to summarize with a note here. Note, in general, the largest power term of a polynomial, now notice we're talking about a polynomial, acts like the longer polynomial at positive infinity and negative infinity, or very large and very small values. Okay? So, if we go back to what we saw on our first example, we saw that when we were at small values, we had two distinct functions. Okay? But here, we had two distinct functions. But when we went to large values, they looked exactly alike. So how does that help us? You're going to like this. This is a way that our life is made easier by this concept of an end behavior model. And this is so important as we move towards the AP exam, because end behavior models save you so much time. All right? So let's do a couple of examples here. Let's say that I was doing the limit as x approaches infinity of 2x squared minus 5 all over 3x squared plus x plus 2. If and only if we are approaching infinity. Now, you can't use this trick when you're not approaching infinity or a negative infinity. But since we are approaching infinity, then we just learned that as we approach infinity, these two little polynomials act just like the highest power terms. So in other words, everybody's greatest fear is to be insignificant, right? To not matter. To, we don't care about you. Well, guess what? All of these, sorry, you're insignificant. Everybody's greatest fear is realized. If I was the +2 on the bottom polynomial, my life is over because I'm insignificant. And so guess what? We can actually rewrite this limit as the limit as x approaches infinity of just 2x squared over 3x squared. And isn't there an algebraic simplification we can do? Do you see something that we can get out the slasher for? Those go away. And what do we have? 2/3. Problem's done. Okay? So if you have an end behavior model, life is good with the polynomial. All right? So, now, what if we had this problem? Another example. The limit as x approaches infinity of 2x squared minus 5 over 3x to the 4th plus x plus 2. This one's a little bit different because when I mark out my insignificant pieces, I'm left with a little bit different algebraic simplification. I'm left with 2x squared over 3x to the 4th. So that means I still have an x in the bottom. When I simplify this, I'm going to be left with an x squared. So what I have is the limit as x approaches infinity of 2 over 3x squared. Now, this is kind of where we can come up with a normal little rule. When I have a constant on top and an x to any power, so long as it's not a negative power, on the bottom, this is going to be 0. Why? Because I've got 2 divided by flippin' huge. If I have 2 divided by something close to infinity squared, right? If I have the little number 2 divided by a gargantuan number, it's going to be basically 0. Okay? So, if you have a constant on top and some x on the bottom that's left, if you are approaching infinity or negative infinity, it will be 0. If you have the opposite, something like this, the limit as x approaches infinity, let's say we've simplified our polynomials and we have 5x over 2. If you have the opposite, what is that going to be? Well, now we have flipping huge just divided by 2. This is going to be positive infinity. Because we're going to have a number so large that even if we divide it in half, it's still going to be really, really large. Okay? So if you have the opposite, it's infinity. If you have the x in the bottom, like we said here, it's going to be 0. All right? So that gets us started on limits and infinity, and we will stop there for today.